Hi there, and you're very welcome to our 11th episode of the Science Lesson Support System, suitable for primary school age from 6 and all the way up to secondary and right through to long life learners. In our last episode, we covered gravity and how these simple little resources can help add connectivity to your existing science lesson plans through overlapping topics and resource integration. These resources are aimed to make learning and teaching science easier for both the teacher and the student. So let's get started. We know a light wave as just visible light, which can be perceived by the human eye, but it's actually just a very small part of the full spectrum of waves. There are lots of different types of these waves, but we call these waves radio waves or microwaves or infrared waves or X-ray and lots more. So let's try imagine what these waves look like and imagine how energy affects them. Students held a rope at each end and pulled it tight and shook it up and down. You would start to see peaks and troughs throughout the rope, and this represents, let's say, a radio wave. But if the students went a little bit faster, meaning that they are actually physically putting more energy into the rope, you would begin to see more waves representing a more energy intensive part of the electromagnetic spectrum. This would be microwaves. Repeat this again even faster again and you get infrared radiation, and on and so the process continues. And just like that rope, as energy is increased, the electromagnetic waves become intensified. And this is how all our modern technology works. You'll see in this chart that the waves are actually compared in size to things like buildings. And they can go all the way down as small as the center of an atom. By introducing our diamond molecule, we can imagine how visible light would bounce around to make your ring look bling bling. But smaller types of the spectrum would blast right through these holes without any problem, and some would interact directly with the atom. The light we see is white light, but even that is made up of lots of other colours. If you could pick yourself up a red, green and blue torch, you can demonstrate this. But an example of wavelengths that's around us all day, every day are Wi-Fi and Bluetooth and car signals, phones, satellite and so many more. But if we could see all of these wavelengths, it would be a fog we actually just couldn't get around. But our eyes evolved to see in the wavelength of light that we see in because it's more useful. However, we have tools to help us detect these hidden forms of electromagnetic radiation. One of the most fun ones is an infrared camera, which we covered in episode 7 in Hot and Cold Things and episode 2 on climate change, where we discussed how light hitting an object can make the atoms and molecules bounce and jiggle and change. Although not important, but it's really interesting to know, each element actually gives off its own unique personal wavelength. Astronomers can tell what a star is made of from millions of light years away. It's called spectroscopy, which looks at the spectral emission lines of a star. The electromagnetic spectrum intuitively overlaps with electricity and magnetism, hence why it's called the electromagnetic spectrum. They are all related. And all travels through the space-time fabric responsible for gravity that we covered in episode 10. Massive gravitational forces can in fact bend light around objects, predicted by Einstein long before it was ever directly observed. Now that's the power of science. We also covered in episode 7 about when light hits a solid object, it can make their atoms and molecules jiggle, so be sure to check that out. I think we leave it there for now. But this image is a really good one to know, and these three little lights and our jiggling molecule from episode 7 and the rope are really good to have to help explain this. Our next episode, number 12, will be the final episode in the Science Lesson Support System series, where we will be taking a deeper dive look into some of the higher optional levels of learning, such as what atoms themselves are made of and how to visually represent that in a display. So thank you for watching. I've been your host, Paul Bruton, and remember, you're not just teaching STEM, you're telling a story, the true story of nature.